I start by opening an assembly. I use the New Study command to create the study, set the study and mesh types, and then select the geometry I want to analyze. In this assembly, a load is applied to the anvil when an object is placed against it and the spindle is tightened. To make it easier to see the load, I hide the anvil, then use the force command to define a direction and amount of force. Next, I apply a fixed constraint to the right face of the frame. With the load and constraint defined, I overlay the model geometry with a mesh and solve the study. Once the solve is complete, the simulation results, including a graph of von Mises stresses, appear in the workspace. Before closing, I replace the graph of stresses with a graph of normalized displacement values. As I prepare to edit the frame part, I can make the display clearer by opening the simulation pane and hiding the applied force and constraint. I'll display them again after I make the edit. I use the context toolbar to edit the frame part in place. When I edit the dimension, the frame part updates dynamically, leaving me in the edit state until I close the part and return to the assembly. When I open the simulation pane to display the loads and constraints I turned off earlier, I see the alert indicating the mesh and results are out of date due to the change I made. I start the mesh command and solve the study again, updating the assembly in the process. Next, I use the animate command to display the part deflection under the defined loading and constraint conditions. I have options on the animate command bar for controlling the characteristics of the animation. I change the frames per second and the cycle length and then observe how the animation updates. Finally, I'll create a report to share the simulation results with others. After confirming the report information and creating the report, the simulation is processed and the report displays in a browser window.